Hello everyone, my name is Nurul Soleha binti Bongsu. My matrix number is BT233030879. So today I'm going to present for part 1, which is construct appropriate graph or chart to compare the relative frequency and cumulative relative frequency between the two indicators, which is production cost and also profit margin. Firstly is relative frequency. Relative frequency is the proportion for each value relative to the total. So for this relative frequency, I use the polygon graph to make a comparison between production cost and profit margin. The graph shows the highest production cost of companies is in the interval range 20 to 29 millions, which is 23% of relative frequency. And for the profit margin is highest at the same midpoint with production cost, which is 24.5 with a relative frequency 0.77 or 77%. So this means the majority of profits are concentrated in this range. For cost midpoints above 44.5, the relative frequency of profit margins drops to zero, indicating no profits in higher production cost ranges. Both variables align best at the 24.5 midpoint, suggesting this is the optimal cost range for businesses. Next, cumulative relative frequency. Cumulative relative frequency is the running total of relative frequencies up to a certain point. So I use an ogive graph to make a comparison. From the graph shows, the profit margin cumulative relative frequency increases rapidly in the early intervals 10 to 29%, while the production cost increases at a slower, steady pace. Between the 10 and 29 intervals, the profit margin curve is significantly steeper than the production cost curve, showing faster accumulation. After the 39 upper class interval, the profit margin curve flattens, indicating that most profit margins are already accounted for, while the production cost curve continues to rise steadily. The production cost curve shows a consistent increase across all intervals, reflecting a more even distribution of cost over time. The profit margin curve indicates a narrow focus on lower cost intervals, whereas production costs are spread out across a wider range of intervals. The difference in slope demonstrates that profit margins are more concentrated while production costs are more variable. So the conclusion is the comparison highlights the critical role of optimizing costs in the lower intervals to align with the range where profit margins are most frequent.
Hello, my name is Hazel Immaculate James, metric number BB231102226. I will present on part 2 a comparison of the measures of central location, which consists of mean, median, and mode between the two key performance indicators in the dataset, which is production cost and profit margin. Before proceeding with the analysis, the data must first be arranged in ascending order from smallest to largest number for median and mode measures. After I calculated the sum for both data, the sum of production cost is 1,484.2 million and the sum of profit margin is 741.7%. Let us begin with the mean. The mean for production cost is 49.47 million, indicating the average spending on production. However, the mean is sensitive to outliers such as Malayan Flour Mills Berhad with a cost of 97.2 million, which is significantly higher than most other companies. As a result, the mean might not represent smaller or more cost-efficient companies accurately. On the other hand, the mean for profit margin is 24.72%, less affected by outliers, providing a reliable representation of overall profitability. Moving on to the median for production cost is 46.25 million, which is lower than the mean. This indicates that most companies have production costs below the average. Meanwhile, the median profit margin is 25.35%, which is very close to the mean, indicating that profit margins are more evenly distributed across companies with fewer extreme values. Finally, we will analyze the mode or the most frequently occurring value in the data set. For the production cost, there is only one mode, which also known as unimodal, with the mode being 36.2 million. This unimodal reflects a limited clustering of costs around this value. Meanwhile, profit margin has many modes and also known as multimodal. There are 6 modes, which are 21.2%, 22.1%, 23.3%, 26.3%, 27.6%, and lastly 30%. This indicates that companies often achieve similar profitability levels. That's all from me. Thank you.
Hello, my name is Ketian Timbang and my metric number is BB233110804. I will present part 3 about percentiles and box plot. For production cost, it has minimum value 11.8 million and for the maximum value it has 19.7.2 million. For the first quartile, it has 26.45 million and for the median or second quartiles is 46.25 million and for the third quartile it has 67.7 million. For the interquartile range, it has value 41.25 million and the outlier value outside negative 35.425 million and 126.575 million. For the inside, majority of data lies within 26.45 million to 67.7 million, indicate moderate variability. And also, the box plot visualize the central tendency and spread effectively. And for the profit margin, it has minimum value 60.3% and for the maximum value it has 31.2%. And for the first quartile it has 21.88% and for the median or second quartile it has 25.35% and for the third quartile it has 27.6% and for the interquartile range it has 5.72% and the outliers value outside 13.3% and 36.18%. And for the inside, profit margins are relatively tight, showing a smaller spread compared to a production cost. And for the box plot, it highlights the stable distribution with minimal outliers. And to summarize, the box plot provides clear visual comparison of spread, median and outliers for the both indicator. And for the production cost, it has high variability while profit margin are more consistent.
Assalamualaikum and a very good morning. My name is Dayang Nur Zarina binti Zamri with number matrix BB23110.168. So for the part 4, we will discuss about calculate and compare measure of depression between two key performance indicators. So here we need to find 4 things, which is range, mean absolute deviation, MAD, variance standard deviation, and coefficient of variation. So the first one is the range. How to find the range? Range is the difference between the highest and lowest value. So how to find the range? We need to minus the range maximum value with the minimum value. So here for the production cost, we will get 97.2 minus with 11.8, so we will get 85.4 million for the production cost, and for the profit margins 31.2 minus with 16.3, and we will get 14.9%. Okay. Next is mean. We need to find the mean absolute deviation. So I already put the formula here how to find the mean absolute deviation. So using the mean given, we will add all the data and then minus it with the mean and divided by 30. So the answers here for production cost mean MAD, which is 649.47, will be divided by 30 and we will get 21.649, and then the final answers is 21.65, and then for the profit margin is 93.63 divided by 30 and we will get 3.120, and then the answer is 3.12 for the mean. And then variance standard deviation. Variance standard deviation. Standard deviation is the square root of the variance and provides a measure of how spread out the data is around the mean. So we will use the variance to find the variance standard deviation. So here we will get 649.10. We will square root it and then we will get the answers, which is 25.42. And it for the production cost, and for the profit margins, do the same thing for the profit margins, but we will get 14.46. We will square root it and then we will get 3.8 for the final answer. Okay, next we will do for coefficient of variation. So I already put the formula there to find the coefficient of variation. So production cost coefficient of variation is 20. We will use the standard deviation and divide it by with the mean. So here we will get 24.47 divide by 29.47, we will get 0.51, and for the profit margins we will use 3.80 divide by 24.72, and then we will get 0.15 for the final answer. Based on the measure of depreciation provided, we can conclude of the following. Okay, the production cost demonstrates significantly higher variability compared to the profit margins, as reflected in its larger range, variance, and standard deviation. This suggests that production costs vary considerably among the companies analyzed, whereas the profit margins show relatively consistent patterns. This greater variability in production costs might stem from differences in company operation scales, industry sector, or business models. That is all from me. Thank you.
Hello, my name is Nur Aina Marshita binti Aliuddin. My metric number is BB233110409. I'm going to present for part 5. First, covariance describes the direction of the linear between two variables, x and y, where x is production cost and y is profit margin. To find covariance, you can use the formula that shown in the slide. So, covariance for the production cost and profit margin are negative 89.62. Next, correlation coefficient describes both the direction and the strength of the relationship between two variables, x and y. To find for correlation coefficient, you can use the formula that shown in the slide. So, correlation coefficient between production cost and profit margin is negative 0.96. This indicates negative and strong correlation, meaning that as the production cost increase, profit margin tend to decrease and vice versa. The strength of the correlation suggests that there are significant inverse relationship between these two variables among the company in the sample. That's it. Thank you.